Hi all. Okay, so if you ask yourself what is this, this is an inverter, a power inverter that is taking a DC voltage and transfer it to 220 volt, and it's capable of 2 kilowatt or 2000 watt, and by the spec it can achieve 2300 without any issue. What I did is connected these big wires here for the battery connection, and there are two outlets on this side, two out and a power button, and I'm going to check it with a fan that consume about 500 watt, because I will not use it more than that for my needs. And how I activate it with a battery of G30 scooter. It's a big battery. It's scooter that you ride on it, because I have few batteries like this. What I do is just connect the connection of the power to the battery, so probably a little spark that you've seen, and I got it with a nice remote control, this remote control that power it on, and you can use the button to power it on. I have also the fan itself. I connected this watt meter, but we don't need it. You will see it without it. And now I'm plugging it to this side of the inverter, and now I will power it on and we will see what is happening. Before I do it, I will check that it is it's closed. This is the fan that I'm using, maximum 2600 watt, but I'm using it on the low heat. So let's power it on, and you can see that we can see the voltage of the battery, 38 volt, 50 hertz, 200 and 20 volt. And now we will do two things. First, we will check the current that is going out of this battery with this Hall effect meter. So now we have already a little current, and we will see that it is real. I will shut it off. You see that it is going almost to zero. So let's calibrate it. Now it is fully calibrated, and now I power it on. You can see it consume about a little less than half amp, and since it's power, so now I will use this fan. It is connected here, so let's power it up and see what happens. So we had 35 volt and about 13 ampere. So we can multiply this number. I don't have here, and I don't have something to measure it on the output right now because it is not connected. I wanted to see the efficiency of this, but you can see that it can drive 500 watt without any issue. Nothing is getting hot. This battery is capable of 20 amp continuous and about 40 amp in peaks, but without the scooter connected, I think it can get up to 20 amp, and that's all. So this is what we have. Also, we have Type C USB out and QC3 and 2 additional USB output on the top. And what is nice is this remote. You don't need to press anything, you just hold the button and it shut off immediately. And in the next videos we will talk a little about how we can know which battery will go okay for our power inverter, and we'll do some calculation to know how much time it can get our things to work continuously. So this is basically all. It's an inverter from AliExpress, but I was searching for one with very good rating, and also I look about the overall how it looks to me, and it's look like a really good one. Later we will talk about pure sine wave. We will check that this should be pure sine wave. This is in order to get the maximum for your battery, the maximum efficiency, which gets to about 90%, maybe a little more than this. And it's very important to be a pure sine wave in order to get the maximum efficiency from your battery and to deliver all the power. Of course, if the power go high to the maximum rating, so the efficiency usually decrease a little, and if you consume less power, so it's better. And this is all first part of this video. The second will be with some more experiment and some technical instruction how to know which battery is good to which inverter, and how to choose your inverter. By the way, this is 36 volt. I chosen it because this is the batteries that I have. The advantages of a higher voltage is that the wire are less big wire, and the diameter is smaller because you need less current. If the voltage is higher, you need less current and you will get the same power. So that's all for now. Thank you and bye.